Welcome back, everybody, to our series on Auto 5s. These are the shotguns that the Browning Auto 5 inspired, the guns derived from it, and today we have a particularly wacky entry in this story. Of course, we're looking at none other than the CZ241 shotgun. Now, the history of the CZ241 is a little bit of a fickle thing. There's a short version of the history, and then a longer version of the history, and then a full version of the history, and the full version is not immediately clear to me, so we'll sort of go with the medium-long version of the history instead. Now, the important things to know is that Czechoslovakia, there after World War I but before World War II, was interested in making auto-loading shotgun. Really, across Europe, there was sort of a push to be investing some amount of money in automatic arms in general. Rifles usually found themselves being more geared towards infantry and military development. However, shotguns across Europe and across the world would find themselves being developed for sporting and civilian sort of use. And it was around this time that Czech arms designers had sort of discovered how they were going to be doing their semi-automatic shotgun. Now, the less often told part of the story is that there was an Italian patent for a shotgun which was more or less mechanically, in terms of the feeding and shell tendering, identical to the way the CZ241 operates. I have not been able to personally see this patent, however, people that I trust and people who know what they're talking about have verified to me that they have seen this patent and that it is more or less identical to how the 241 works. So at least some pieces of the way the 241 operates are not unique to the 241 itself. And in fact, there was an Italian prototype gun coming out of the 1930s that featured all or some of the shell tendering system from the CZ241. And really the most interesting and mechanically unique thing about the 241 is that shell tendering system. We'll get a better look at that later once we've got a better grasp of the history. Initial production of the CZ241 just targeted 16 gauge, and the 16 gauge guns are by far the most common that you'll run into. However, 12 gauge and 20 gauge guns were eventually added. However, the production run of the 241 was very short. As we just mentioned, the gun's design was more or less hammered out right before World War II, but what with Nazi occupation, the 241 really wasn't put into production until after the war, and certain parts of the gun then used scrapped or recycled war material pieces. As the story goes, the barrels on the 241s are made out of forged pieces of steel that would otherwise have become the barrel for a cannon, ended up becoming the barrel for a shotgun, and supposedly the aluminum for the trigger guards and the very rare aluminum receiver guns were made out of aluminum reclaimed from aircraft parts. There's different versions of the story that have different levels of believability. One version is that the aluminum was all recycled from shot down US bombers. I don't believe that there'd be that much aluminum because these guns were made in pretty decent numbers, so that one I'm not so sure of. However, there's also been claims that they were made out of German aircraft engine parts as well as German aircraft propellers, and that would be a lot more believable, A, because the Czechs were already doing some of that aluminum work, and then B, there'd be a lot more of that material just sitting around by the end of the war, as opposed to pieces of airplanes that have been blown up in the sky and then scattered over a mile-long debris train, then going and picking the aluminum out and making a pile of it that you'd then save for after the war to make shotguns with seems a little unlikely, but I digress. Now, that production after the war didn't last very long because, of course, Czechoslovakia went out of the frying pan and into the fire. They got rid of their Nazi occupation. Well, they didn't get rid of it. The other countries got rid of it kind of for them. However, then they were independent for only but a few years before the Soviet Union scooped them up, and again, sporting shotgun production halted. And for the 241, that production was never to begin again. Production numbers were fairly decent, and you'll find that in the US, these aren't very common guns. As far as I've been able to tell, there was not a contemporary importer of these things. However, back at that time the guns were in production, you wouldn't have needed to import mark guns the way that you need to today. So figuring out whether or not there was an importer in the US at that time has been seriously difficult for me. However, the guns have been sort of trickled into the country afterwards in onesie-twosie imports. And because the production numbers on them aren't bad, you can find them in Europe pretty frequently still, and find them imported to the US still. Which is cool because for as unique as they are and as little known as they aren't actually terribly rare compared to something like maybe the Recoil, right? The inertial operated shotgun. Very rare gun that was only made for 1 year a long time ago and was never imported officially into the US. Very, very hard to find examples of those. Meanwhile, these are more plentiful, made more contemporarily, and in my opinion, it's at least as cool as the heel grind, but more available, which is good. Now, that pretty much wraps our discussion of the history, right? It bleeds over, some of the guns get imported to the US, and that's about it. It ends up being more or less an evolutionary dead end, except for one small part of the mechanism, which we will see later. And if you haven't watched the Browning double auto video that I have on the channel, go ahead and pull it up as well, because there's an interesting crossover that once we see the guts of this gun, we'll be able to say, aha, I've seen that before, if you've already seen the double auto video. But if not, you'll see it here and then see it in the double auto and go, aha, that's where Val Browning got it. So there's one small part of this gun's mechanism that, as I've been informed, actually dates back to that Italian design, where the way that the shell tendering in this gun works comes from that Italian design, gets copied here, and then gets heavily borrowed from in the Browning double auto. And we'll be able to take a peek at that as we get the guns cracked apart. Now, we have here a 12 gauge gun and a 16 gauge gun. Both of them are functional, both of them work well. When it comes time for disassembly, I'll take the 16 gauge gun apart, but I did want to show these two. I have not been able to find a 20 gauge gun. They are by far and away the rarest of them. I have never actually seen or verified that there is a 20 gauge one of these in the US, although I don't doubt that there is. I've never seen one sold or available for sale or shown off by somebody who is in the US. So certainly the 20 gauge guns are the least common. 12 gauge are uncommon, but you can find them sometimes, and the 16 gauge guns are pretty much run of the mill. Very interestingly, the guns are scaled action. I would not have expected this with as short as the production run was, but the 12 gauge gun is substantially larger in pretty much every dimension that it would need to be than the 16 gauge gun. It's got a wider receiver that's quite a bit bulkier. It's got a barrel with a completely different profile. The internal parts, even in some places, are scaled slightly. And what this really means is that, the 12 gauge gun weighs as much as it needs to, but the 16 gauge gun is incredibly light and svelte and pointy in your shoulder, which you probably, again, wouldn't expect from, the Czechs aren't known for their automatic shotguns. And this one certainly wasn't one where a lot of forethought went into its design. It was sort of a pie-in-the-sky idea before the war that got brought along to fruition after the war. And yet the 16 gauge guns in particular do point and shoot really, really nice. Now, before we put the 12 gauge gun to the side and then get into the mechanics of the 16 gauge gun, one very important thing to mention. If you're sitting there thinking to yourself, boy oh boy, I really want a CZ241, it's time for me to wrap you in a wet blanket. Because these guns have one weird quirk about them, very similar to how the double auto has a weird quirk about it. Because of the way their shell tendering system works, the overall length of the shell becomes a critical dimension in the gun's ability to feed itself. And of course you may be there thinking, well, okay, but modern manufacturing tolerances these days, right, the variation that you'll get in one shotgun shell to the next is maybe 50 thousandths of an inch. There's no way that matters, right? Correct, that's true. 2 3/4 inch 12 gauge wasn't really a popular thing in Europe when this gun was made. 2 3/4 inch 16 gauge wasn't standard even in the US when this thing was made. As a result, both of these rely on a very, very specific shell length that you can't really find commercially manufactured anymore. The 12 gauge guns want 2 5/8 inch roll crimped shells. As far as I've been able to tell and from measurements, that's about what they want. However, a 2.5 inch star crimped shell is almost long enough, and with some internal tweaks and modifications, you can get them to feed it and cycle it reliably. The 12 gauge guns cannot be made to work with 2 3/4 inch unless you're okay milling on receivers and reaming out barrels and doing all sorts of really weird wonky stuff. So the 12 gauge guns are very difficult to feed. You can modify them, adjust them to get them to work correctly with 2.5 inch star crimp, which is available these days. But what it really wants is a 2 5/8-ish roll crimp shell that hasn't been manufactured for a moment, at least not in the US. So feeding the 12 gauge guns, tricky. The 16 gauge guns, interestingly enough, because of the smaller diameter of 16 gauge, you can convert these guns without modification of the receiver to work with 2 3/4 inch 16 gauge. Ordinarily this would involve reaming out the chamber. On this particular gun, the chamber isn't reamed out. So if you're in the camp of feeling that using a 2 3/4 inch shell on something like a 2 9/16 inch chamber is unsafe because it'll cause a pressure spike, you would want to have that corrected here. I didn't do that on this one because I'm not necessarily in that camp. If you're doing it very large leaps, like taking a 2 inch chambered 12 gauge and putting a 2 3/4 in it, that's going to end up causing a problem. However, very small differences, like you'll have going from like 2 9/16 inch 16 gauge up to 2 3/4 inch 16 gauge, the amount of shell that you have opening into the forcing cone is very slight. And all of the pressure testing that people have done of this that I have seen shows that there is not a measurable, not a nominal increase in the chamber pressure as a result of that. And so while I'm not recommending that you go and do any particular thing regarding putting shells in chambers that are too short for them, I'm okay with it, at least with guns that are made relatively well. And I would include these guns in that category. So with that side note, the point is, you can get the 16 gauge guns to work with 2 3/4 inch 16 gauge. However, as we'll go over whenever we're looking at the internal mechanism, the mechanism itself does need adjusted for that longer shell length. On this particular gun, I'm using a 3D printed part to do that. However, on my 12 gauge gun, in order to get it to run 2.5 inch shells, I ended up just getting a flat sheet steel and then bending it up to sort of replace the factory part, only have it adjusted for 2.5 inch shells. But we'll get a look at all of that as we tear through the mechanism, and so for now, we're going to put Mr. 12 gauge to the side. Now, with just our 16 gauge gun, we can sort of go over the external features of the gun before we dive all the way into its mechanism. We will go ahead and do effectively a full strip of these guns because there aren't a lot of videos that show that in very good detail, and a full strip is more or less required to completely understand the weirdness of the mechanism that's going on inside of here. But, just to give you guys a look, sort of an overview of the gun, you have a slightly round knob stock that's really closer to being a straight stock than a round knob that I find particularly comfortable. You have a very trim, narrow forend, and that's because there's no magazine tube out underneath it, as we'll see in a moment. You have a modern crossbolt safety and a loading door here on the bottom of the gun, which is how you facilitate loading. And while you may think, okay, well, there's no magazine under the forend, that means this is weird and you must load it backwards, right? Well, not quite. You do still load it forward. It's just that this gun has a total capacity of 3 rounds. 1 in the chamber, plus 1 here and 1 here, 2 underneath the action. Now, I can hear the criticisms already. Only 3 shots in an automatic, blah, 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 right? We've been over this before. 2 shots is really all you need in an automatic, and so having 3 really isn't bad. However, this wasn't done for hunting or regulation reasons. There weren't a lot of the laws that we're familiar with today that limit you to 3 rounds in the gun whenever this thing was around. As far as I've been able to dig up, the CZ241 was sort of doing that trade-off, right? Finding the perfect autoloader wasn't something that had a ton of shells. It was one that had just enough shells, and that 3 was probably just enough. And while my gut instinct is, especially after handling the double auto a lot, is that 2 is probably even enough, that comes with the caveat that the gun needs to be really quick and easy to load. And this gun is not quick nor easy to load. In fact, it's a little bit of a bear to have to deal with because, of course, this door has to be slid open, and then you have to put 1 shell in and then push it all the way forward with your finger way up inside the gun, and then take another shell and then put it in behind it. Oh, and if you thought that you could put those shells in there before you put 1 in the chamber and you could just rack a shell into the gun, you'd be incorrect most of the time because the gun doesn't like it when you do that. The gun prefers that you put 1 in the chamber first and then 2 in the bottom. And we'll sort of showcase the weirdness about loading it in more detail whenever we get to the shooting segment. But until then, there's really only one last manual of arms things we need to talk about, and that's this weird charging handle system. Most people, their first time handling a CZ241, are capable, right? It's a normal charging handle, right? You pull the bolt back, and then they will look all over the gun to try and find the bolt release. The funny thing about this gun is that the charging handle is the bolt release. The charging handle sort of sits on a pivot there, and you pivot the charging handle down to get the bolt to go back forward. This is not a particularly intuitive system. However, once you've gotten used to it, it's really kind of brilliant because you don't have to change your hand position, right? If you got the bolt locked back, you now don't have to change your hand position at all, like to press a separate button on either side of the gun. The charging handle is your bolt release, and in that regard, it is pretty cool. That said, I have seen several of these guns with this charging handle mechanism broken off of it, and people start drilling and adding screws to the bolt latch to be able to remove it by pulling down here. There are certainly some abomination version of these guns out there. I think A, because people don't understand how they work necessarily whenever it comes time to gunsmith on them, and then B, these are not the most robust guns. The core mechanism of the thing is pretty strong and well thought out. However, there are pieces in the gun that are not very well engineered, and certainly the charging handle and the way it attaches to the bolt itself I would include as one of them, because I've seen several of these guns that have that piece break. However, with that all addressed, I think we're about ready to start taking the thing apart. We'll lock the bolt back, pull the barrel down just a little bit, and remove the handguard. The handguard screws can be really hard to deal with on these because they are so petite, right? It's a very small diameter screw, but with that off, we can see it's just like a little itty-bitty Auto 5 version thing. And then our handguard comes off, and we can see, well, it's pretty much just a very skinny little handguard, right? I guess it's thicker than it needs to be. Compared to the Cosme, this is an overgrown fat handguard. However, compared to anything else, this is like a 410 gauge sized handguard. It's very, very slender. And with that removed, our barrel will come off, and we're able to discuss a couple of things. First off, on the barrel, there's no rails on it, right? On the Auto 5 barrel, we're used to having rails that ride in the receiver. In this, you just sort of have a square lug protrusion on the bottom of it. What this really means is that the up-down location of the barrel is not set by those rails, it's set by the barrel rubbing on the top of the receiver. On an Auto 5, the top of the receiver isn't structural. In fact, the bolt and barrel aren't supposed to be rubbing on it at all. On some guns, you can find wear marks where sometimes they do, but it's not supposed to be happening. The CZ241 departs from that. Instead of having to cut keyways all the way back through the receiver, it just has the barrel ride such that it rubs on the top of the receiver. It's not bad to do this, it's just that you need to have a little bit more strength and structure in your receiver than on the Auto 5. Ultimately, I don't disfavor what's done here. It is a cost, I would characterize this as a cost-cutting measure, but it's not necessarily a bad one. We have a lightning cut here on the side of the barrel to save a little bit of weight, and we can see that our barrel hanger here is done very interestingly. Part of the base of it is integral to the barrel, and then the actual hoop itself is dovetailed into that base and then staked in place. I'm not sure if these were then silver soldered or not, but as far as I can tell on this one, it looks like it may have just been staked into place. It's a very interesting way of doing this. I don't know that it necessarily makes me feel extremely secure about the strength of the gun, because if that staking failed, of course, your barrel would then come off of its hanger, and while the barrel wouldn't necessarily be able to rocket its way off the front of the gun, it is going to probably cause damage to the rest of the gun. But I can say that in all of the ones that I've seen or handled or worked on, I have yet to see one where this was failing, so maybe it's just okay, even though it's a little bit unconventional. Moving forward, the guns that don't have a rib have an integral sight base on the barrel here, and then a front sight bead wedge thing pinned onto it. I like the pinned-on beads. I know that this might be controversial for shotgun people as opposed to the screw-in beads. I've seen screw-in beads fail a lot more often than this, and if you wanted to adjust the sort of height of impact or anything like that with this sort of a system, you just drift a pin out, take the sight out, put a new one in, put a pin in, and then you're back in business. Whereas with beads, it gets a little bit more awkward than that. But this is about what we have for the 241's barrel. Set that to the side. Next up, we have our friction system. We have a recoil spring here and a friction brake here. Now, ordinarily, there is a control ring that sits between the recoil spring and the friction ring, like so. However, this control ring is off of the 12-gauge gun, and then also this is the friction brake off of the 12-gauge gun, just for comparison. It does have a tension band to give it just a little bit more effectiveness in comparison to, the 16-gauge gun has no such tension band. I have seen 16-gauge guns with friction systems that look like the friction system from the 12-gauge gun, so I'm not entirely sure if throughout the generations of the gun, throughout the gun's development, they ended up consolidating on a friction system that was designed like this, or if parts have just been swapped between guns willy-nilly. However, the recoil spring just pushing on this friction brake will work, right, because the spring has ground ends. It's not going to damage the friction brake to have it done that way. However, having the control ring as an intermediary is probably important. It would be a good thing to do. However, because I only have one of them, I just have to swap them back and forth between guns. It's a simple enough part, I could probably just end up making one, but because I've got the two guns, it's not necessarily hard to swap between them because I'm not usually in a situation where I need to shoot both of them at the same time. The friction brake system on these guns does work, right? It is effective, it works the way it ought to. In fact, they're sprung more like an Auto 5 than like a Cosmi, right? This isn't as heavy a spring as you'd see on something like the Cosmi. And as a result, these guns do shoot fairly smooth. However, that should be understood with the caveat that the 16-gauge gun is pretty lightweight, so it does still kick fairly hard. And because the 12-gauge gun that I've got is really limited to 2.5-inch shells, it's shooting pretty darn light loads in the first place, so we would kind of expect it to be fairly gentle on recoil. But with that in mind, the guns do both shoot very adequately. When I took the 12-gauge 241 hunting, I sort of had one of those miracle moments where as a blocker, I had 3 birds coming at me, and I knew I had 3 rounds in the gun, and I was like, this is my moment. And so, bang, hit the first one, bang, hit the second one. And then the gun had a hang up on feeding the last round, and so it just sort of required a quick pull back and then push forward on the charging handle, then bang, was able to hit the third one. And I felt so cool with my silly jacked up 3-round gun that you would hit 3 birds. And then begins the long process of reloading a 241, where it's plunk in the chamber, close the bolt, open the door, 1 shell, 2 shell, close the door, and now you're ready to go again. All that to say that certainly whenever the guns are tuned up right and set up correctly for the shells that they're using, they are totally useful for hunting. As we go through and sort of look at how weird these things are, I don't want anybody's takeaway to be they're too weird to work correctly, because they do work well. It's just well with an asterisk. There's certainly a lot of guns that work better, but the weird things that are going on here aren't necessarily bad, because the 3-round capacity with as light and pointy as especially the 16 gauge guns are, is really nice, and ultimately that will be the big takeaway. Skipping ahead to the conclusion just briefly, the 16 gauge examples are really, really nice, and because they can be so easily converted to 2 3/4 inch, which is very common 16 gauge ammo, they are, I think, my pick as far as what's best to have in a 241. I think it's a converted 16 gauge gun. Meanwhile, with the 12 gauge guns, right, you can convert them to use 2.5, which is the rare and expensive 12 gauge shell. You can't convert them to run 2 3/4 without doing bad things to the gun, right? A lot of milling on receivers and barrel extensions, and really boogering the gun up pretty bad. But that discussed, we're ready to set our friction system aside with the understanding that it does work and the guns are quite usable. At this point in disassembly, we're now ready to take the side panels off. People look at this gun, right, it's the Jeep Wagoneer of shotguns, as it is often comically described, because it's got these wood panels on the side. And I have seen people surmise that those must just be for aesthetics, that there's not a functional purpose. And that's pretty much true of our left-hand panel here. You could shoot the gun with its left-hand panel off, and that would just be okay, right? Nothing's going to get hurt as a result of the gun having its left-hand panel off. I suppose you could have foreign debris infiltration, but you're not going to lose any parts, as opposed to the left-hand side of the gun. The panel is what holds some of these internal pieces of the mechanism in the gun. So for example, right, with that panel off, this piece can come out. This piece, as we'll see later, is pretty important to the way that the gun works, but it works as a combination of kind of your bolt hold open, but really more so it's the intermediary that releases the bolt as the carrier comes up with the next shell to feed. And so having it out of the gun completely prevents the gun from working correctly, and that panel is all that holds the thing from falling out of the gun. But because of that, we will slip it out for now and set it to the side, because we don't want to have it drop whenever we're not paying attention. At this point, we can point out one thing that is incorrect about this gun, and that would be this pin here. Ordinarily, this is a screw. When I got this gun, there was no screw nor pin at all here, and the trigger group had a little bit of wiggle, and that actually contributed to the crack that you can see down here on the stock. It's not uncommon to see that crack, and on at least one other gun, I found it also missing the screw. I don't know if maybe these screws were poorly heat treated on the original guns and they would break and then just get discarded by people who go, well, the trigger group mostly still holds itself on there, but when that screw is missing, it's really the stock that's holding the trigger group on the gun, and the stock is not designed to do that. And so as the bolt comes backwards and pushes down on the hammer, it's putting a lot of stress on the stock. And you'll see some stocks get cracked all the way back through the whole thing, right? The whole bottom half of the stock is trying to come off because that screw is either missing or damaged or not installed properly. So that is one difference there, is like on the 12 gauge gun, right, I've got a screw there. But in this case, I've got a pin that I spun down to the right diameter so that it holds everything the way it's supposed to without it necessarily being screwed in. Now, with the gun taken apart this far, we can gently ease the bolt forward, and now we've got to get the stock off, which means it's time for everybody's favorite parallel ground screwdrivers. And we'll find the right bit here. Ooh, that one fits very well, but is maybe slightly wider than we need. So we'll go to this one right here, and we'll pop the stock off. Of course, we've got our usual 2 screws in the butt plate. Once the butt plate is off, I will show you guys what we've got underneath there, because depending on the age of your 241, you'll find one of 2 different things. The actual way that the stock takes off was modified slightly on later production guns. And both of the examples I have here today, unfortunately, are those later production guns, so I will not be able to show you what the other variant looks like, but I will be able to describe how it works. So you won't be scared if you've got one of these things and run into it. So there's our 2 screws. There's our original butt plate, which you don't always find, but it doesn't like have a cool logo or anything on it, but set that to the side there. And now we have our stock. I have found one of three things once you get to this point on the gun. The first thing is a little metal plate like this that you have to push in and then rotate, and then the action spring will be able to come out of the gun. All right, that's the first one. The second one I found is that on late model guns, there will be a similar plate, but there'll be a slot in it for you to stick a screwdriver in to make it a little bit easier to deal with. The final thing I've seen, which I've seen now on 3 guns, which is too many guns for me to assume that it was just somebody messing around or that it was just one gunsmith that did a bunch of guns up like this, and they were all fairly early production guns. But what I had found was there's just like a little metal plate that has a screw top and bottom, and once that screw is removed, the action spring can come out. I'm not 100% convinced that was factory, however I've seen it on 3 different guns now, so maybe it was just a common fix for if this plate got missing or damaged, but in general what you do is you push in on this plate and then rotate it. It only rotates one way. I always forget which way it rotates, that's the way. And then there's your plate, and really that's just your retainer there for the action plug. And the action plug itself is this wooden dowel rod. And then that wooden dowel rod is then holding the spring in, but usually the spring is shy and it won't come out of the stock on its own. There is a stock bolt independent of that though, and that's what we will remove now. You will find yourself looking at 2 holes. The bottom hole is the one the stock bolt sits into, and we're just going to use our custom tool here, which is a piece of key stock that I've ground a flat blade into for reaching deep into stocks. Let's see if that doesn't get it loosened. I think we slipped out there. Yep, we're getting the stock loosened there. It's a little bit of a tight fit down inside that hole. Of course, if you're using a regular screwdriver, it won't be nearly as tight a fit, but using my funny method here, it will be. With just a few more turns, we'll have the stock off of there. Just like so. And as you're taking the stock off, right, if your spring didn't want to come out with the action plug on its own, keep in mind that that spring will be in there, so don't try and twist your stock. You should never be trying to twist stocks off of guns to remove them, unless you know for a fact a stock is capable of twisting. I've seen recently broken stocks on guns as a result of people that got the stock bolt out and then took the stock and started trying to twist it to wiggle it off. Don't do that. That's generally not advisable. But here we can see our stock, and we can see the cracks this side and this side as a result of that trigger group not really being held on there correctly whenever I got the thing. But there's your stock. They are kind of fragile. You'll see this one's got the crack, right? It's got a crack that will start up here and then will usually terminate by the time it gets to the comb, because the comb is quite thick. But because it's got these sort of 2 unsupported areas, not dissimilar to the Cosmi really, and that really might make you wonder. The Cosmi shotgun was certainly in production and was certainly something the Czechs could have seen, so it's not impossible that this stock played some influence there, but of all the things from the Cosmi designed to copy, the stock's probably not one of them. But this shape here does just sort of remind me of that stock to some extent, right? The tall walls that are both divided, relatively thin out here. Regardless, we will go ahead and set the stock to the side. We've still got our bolt, our sort of, well, really it's a nut for the stock retaining. We'll just leave it in there and set the thing over there. And now we have sort of the core action group. We'll take this spring off. You can see that this spring is a little buckled on mine. May end up replacing it eventually, but for now it does work correctly. Sort of a funny thing about the gun is that there is no action tube back here. The spring just rides in the wood of the stock. That's not a fantastic design choice in my opinion, but otherwise that's just your action spring plug on a spring. Works pretty much just like the Auto 5s does. Our next step in disassembly will be to remove the trigger group. We can flip the action over, and of course ordinarily this is a screw, right? I'm going to say this again, ordinarily this is a screw. If you've got one of these guns, do not try and hammer this out, because ordinarily this is a screw. But there we have that come out, and you can just sort of see it's the pin that I made to approximate that screw. I'll set that to the side. Maybe eventually I'll make a proper screw for it, but we then have the trigger group to this state of disassembly. At this point, the trigger group sort of like wobbles to come forward just enough. It's a very, very awkward series of movements to get it out of the gun at this point, where it will come forward and sort of lift up, and right, you're trying to get it out of this notch back here. And some of them it'll be very tight, some of them will need tapped out with a hammer, but do not go nuts because the aluminum of this trigger guard is really, really soft. It's like almost flaky, buttery soft, and so certainly be gentle, right? That's the moral of the story. That gets us to our trigger group here. The one lesson that I would give you with the trigger group is do not disassemble this unless you need to, because it is hilariously difficult to get back together. Sort of one of those jobs that you wish you had 3 hands for, and you will also suddenly become aware of your own lack of hand strength as you're trying to get the various pieces of this trigger group to sort of line back up with each other. It's a real mess of a trigger group to get apart and back together. However, it's certainly not impossible. And then we have a stud back here. This is the stud that the stock cinches up on, and it is pinned to the trigger group there. In case for some reason you've got damaged threads, you can replace it, right? It is a replaceable piece. The way that the trigger group works is kind of interesting. It really just uses a simple slip sear mechanism. So we can pull the trigger, and you can see the foot on the trigger rise right there. Ordinarily that would be pushing here on the sear. This mechanism there is a part of the sear. Whenever the hammer gets cocked backwards, it will latch underneath the sear. Whenever the sear is in the latched position, the foot on the trigger can interact with it. So if we hold the hammer back, you can see the sear move, and you can hear the trigger foot click off of it. But if the hammer is not held back, right, it will come forward under the pressure from this mainspring whenever the trigger is pulled, and then the trigger will slip off of the sear, allowing the hammer to come back under the sear again. Pretty simple, all things considered. All right, with the trigger group investigated, I'm going to cock the hammer back down, throw the thing on safe, and all the safety really does is block the movement of the sear. It doesn't actually block movement of the trigger, because that foot on the trigger is pushing up on the sear, of course. The trigger doesn't really get to move because the sear is blocked, but that's our trigger group. Again, I recommend against taking this apart unless you've got some problem. I have seen a couple of these guns where the foot on the trigger has wore down to the point that either it won't release the sear far enough to release the hammer, or it doesn't disengage from the sear at all. So of course, with the trigger fully pulled, it still stays with the sear pushed back, and so if the gun's trying to feed, it hammer follows, and this thing will not fire on a hammer follow, but of course you would then have a dead trigger. So sometimes it is necessary to take this trigger group apart to work on it, but if you can avoid it, it's best to avoid it. It's definitely one of those things where if you've got if you've got one that's dirty and it's dirty enough you feel like you need to clean it, just throw the whole thing in an ultrasonic cleaner. Even though that will make some people's skin crawl because you've got the metal vibrating against each other and it can wear off finishes, it's worth it to not to have to pull this whole trigger group apart because it is a little bit of a pain. But there's your trigger group. It is entirely serviceable, right? All the pieces of it can be taken out. It's just one of those things where you don't really want to have to. Put the trigger group there to the side. And we're back to our action here. At this point, we can start taking out some of the internals, but we will save that until we've got the bolt removed. Removal of the bolt is facilitated by first removing this screw. I want to stress how bad I think this design is that you've got a disassembly screw. I don't like the Auto 5's taper pin. I think I'd rather have the Auto 5's taper pin than a screw that can get stripped out or damaged or just come loose from shooting. And so it's really not a solution that I am a big fan of as far as holding the bolt group together. However, we will get a screwdriver that fits the screw, and in fact, looking at that, this screw is loose enough. I was just able to get it with hand pressure, which is certainly an interesting sign. Definitely, if you own one of these things, you will want to check the tension of this screw periodically, because it's a tiny little screw, and it's not something that you just want to tighten up as tight as you can get. It's not something you want to Loctite because you have to take it out every time that the gun gets taken apart. But if you leave it too loose, it will then vibrate itself free as a result of firing. At the very least, it could have benefited from a lock screw or something. But with that screw removed, the charging handle can now come to the rear, but we will have to mind the whole action bar assembly in this gun, because it is going to come out the back of the gun as the charging handle is manipulated, like so. Pull the charging handle back part way, and then this part of the guts of the gun comes out. Ordinarily, we would just call this the bolt tail, only on this gun it's doing a little bit more than that. This wedge here is responsible for accomplishing locking. This round shaft here sits inside of the bolt to sort of ride inside of it to help facilitate that locking. But this isn't the firing pin, this is sort of an intermediary. If you're familiar with the VZ61, it also has an intermediary firing pin, but it's not on some cockamamie linkage. It's just like there's an intermediary and then the firing pin. It could have just probably been all one firing pin, but was done separate for safety. This was done because you have a shell sitting underneath here whenever the gun is normally loaded. So you have one shell here, the bolt here, and then the chamber here. So because of that, it needed something to move the hammer's impact forward to the firing pin. And so that's this somewhat complicated mechanism. It's certainly a piece that if this broke, you would not have a fun time making a new version of it. But with that then removed, we can turn the action upside down and then wiggle it a little bit. Once the locking block rises, the charging handle can come off the bolt, and now the bolt can come forward. As the bolt comes forward, we will note that there is a foot there on the back of the bolt. It's really just like a little flapper. That flapper has to be pushed up in order for the bolt to come out of the gun. So before we do that, we're going to dump our charging handle out. We can see our charging handle has this sort of flag wedge shape on it. And this is how the charging handle interacts with the action to help facilitate unlocking, because the charging handle is just going to be pushing back on this assembly. So we'll put that assembly there, put the charging handle there. Now we are ready to squirrel the bolt out of the gun, which is going to involve pushing up on this flapper once to get it over the plunger, and then twice to get it out of the receiver. And this one can be a little tricky, but there we go. There is our breech bolt assembly. We can see single extractor design. The extractor it does have is fairly beefy. We have our locking block there that rises and falls. And now out of the gun, we can sort of observe how the charging handle itself, we can see how the charging handle itself doesn't actually operate that locking block. It's this mechanism here that does. And then there's a particular order that these have to be assembled in. Right, so the charging handle needs to be on the bolt first. And then the locking block pusher upper assembly comes forward. Right, and in there you can see it doesn't push up much, but there's your locking block, right? There's your locking block popping up. You can see your intermediary for striking the firing pin is right there. And there's that transfer bar mechanism, and you can see how the charging handle itself, all it really does is push backwards on your mechanism here, and then that mechanism getting pulled back is what retracts the locking block. That's more or less the action of the gun insofar as locking and unlocking, because of course as the bolt comes backwards, hits the back of the receiver and then comes forwards, the bolt gets latched by this bolt latch, pulls the charging handle backwards, which is what unlocks the barrel and allows the barrel to go forward. Once the barrel's forward, it then initiates the feeding cycle, and as we saw with that little silver arm that sits there, once that arm gets tripped by the feeding round, the bolt is then released to strip it and chamber it. So that's more or less the way that the individual round chambering part of the action operates. It's the one round to the next part of feeding that's particularly interesting about this, and we'll spend a little bit more time explaining. Now, the last couple of things to see here is that it is a sprung firing pin. You can see the spring through that hole. It's a square locking block, nothing necessarily revolutionary going on there. This little spring guy there on the bottom of the bolt that we had to depress in order to get the bolt in and out of the gun, its primary purpose is to push shells forward, because of course as the gun fires, the bolt is going to come backwards, and in that state, this is going to be folded up, because the locking block is going to be latched into the barrel, so the gun's going to be locked, so this flapper is going to be in its unflapped position, right? It's going to be folded flat with the bolt. Bang, the gun fires, the bolt comes back, the charging handle gets stuck on the latch, then it pulls this mechanism here back, and then we have the flapper sticking forward. What this is going to do is that if there is a third round in the gun, right, the second one put in the bottom, this flapper will push it forward to the primary position there on the carrier as it chambers the round that was previously on the carrier. To give you a better idea about how that works, we have 3 hyper-realistic snap caps. So after the gun is, as the gun's prepared to be fired, right, you'll have one round in the chamber done up like this. Bang, the gun will fire. The bolt will come backwards, again with the barrel still locked into it, but you're going to have 2 shells underneath the action still. The bolt will come backwards, come forward just slightly, enough for the charging handle to be pulled backwards. The barrel will come forward and it'll eject the shell that was just fired. Now, the bolt is going to come forward, but this foot is going to drag this shell forward. However, it dragging this shell forward is not what's going to be pushing this shell, right? This shell is already latched fully onto the elevator. So the elevator is going to pick it up, put it in the way of the bolt. As it comes up, that's what triggers the bolt to release. And then the bolt is going to have this little flapper on the bottom of it push this shell into this position as it chambers this shell. That's more or less that part of the feeding mechanism paired with how the action works. We need to understand that so that we can fully understand how the rest of the actual shell tendering works, because it is interesting. It's different anyway. But there's that part. I don't think we need to strip the bolt, right? It's just a solid pin to get the extractor out. Nothing fancy going on there. A solid pin here to get the firing pin out. When I got this gun, the firing pin was in 3 pieces, so I had to make a new one for it. I just made it out of 4140 and then hardened it with a map torch, and it's been holding up fantastically so far, so I'm not going to do anything to mess with it. But there's the gist of that mechanism. So we will go ahead and get our charging handle back out of the bolt. There's our bolt block, and you can see the bolt has to have this raised section here at the back, and the reason for that is A, it locks into the barrel, but B, the bolt also doesn't have rails on it. Just like the barrel doesn't have rails in the receiver it rides on, the bolt doesn't. And so whenever this whole thing is sort of unified, this is all wear surface on the top of the thing as it rides against the top of the receiver. And we can see here with our receiver that it's a little bit thicker up top than we're used to seeing on 05. A little bit more substantial sides, a little bit thicker at the top, because the barrel and bolt assembly is riding up against the top of it. And it'd be tricky to show to the camera, but you can definitely see finish wore away from the top of the receiver that on an 05 you don't usually get to see. Now, looking up here at the front of the gun, we can see something interesting. We can especially see it through this window. We have a plunger which is holding down the carrier. This is really the gist of what the double auto copied from this gun. This plunger mechanism is exactly lifted. The way it holds down the carrier is only slightly different. If we move our feed door to the forward position, and of course with the pieces off the gun this is a little strange to do, but if we take this shell and then push it forwards, we'll be able to see, of course I guess it's better to see from this side, how that shell will start pushing that plunger forward and then have it depress the carrier hook off the plunger. Now when this shell is underneath a closed bolt, it will just be in this position until the bolt comes all the way backwards and then gets locked open, at which point the carrier will throw that shell up at the top of the gun, and the bolt will of course then try and feed it up into the chamber. Now if we depress the carrier, we'll see that unless there is a shell in the way, the carrier stays locked on that plunger. It's difficult to understand how the double auto works because it's only 2 rounds, right? There's only ever 1 round on the carrier. And because of that, the carrier here needs this little latch mechanism on it because it can have that extra round behind it, the extra round that ends up being fed into it. So there's an extra state that this carrier can find itself in. However, the double auto is then really just a simplified version of this same system. The way that the carrier interacts with that plunger is effectively the same. However, in the double auto, you sort of just have a wall, right? A rear wall at the back side of this plunger carrier interaction, which is responsible for setting the shell length, right? As far as how depressed that plunger gets, because of course whenever the plunger is fully depressed, it's trying to let the carrier come up. On the double auto, that's just set by the rear wall in the receiver/trigger group union, because it's only a 2-round gun. Because we're a 3-round gun here, we need a very special part that's capable of being that wall that prevents rearward movement of the shell on the carrier, but can still let a shell come past it this way. And that's this part. This is probably the weakest part of the CZ241's operation. When I got this 16 gauge gun, mine was bent out of shape and damaged, and my first attempt to try and correct it revealed it was cracked, and so I ended up giving up on that piece. At the time, I wasn't very confident in my ability to do the sort of finicky spring metal working to make a new flat spring, and so I just opted to 3D print one, so we have a nylon piece here that stands in that role. If we take a shell and then push it in, more or less doing that same experiment that we just shown, we'll see that the shell itself will push this piece of nylon out of the way just slightly. Of course, it's a very slight movement. but that piece of nylon will end up getting pushed out of the way for the shell to come past it. But once the shell is past it, the piece of nylon springs back down. It's essentially just like a little gate flat spring, is probably the best way to describe it. And all that gate is doing is making it so whenever a shell has come past it, the shell can't come backwards, right? The shell can't get forced forwards, and the shell is sort of set against a rear wall, and that rear wall will allow the plunger to be fully depressed. That's really all it's doing. Is this arm is responsible for calibrating the shell length sensitivity of the gun. We explained before how sensitive these guns are for shell length. That's because the finger on this piece will sort of have the shell sit at a predetermined location. If that location is too far back, the gun won't be triggered to feed because the shell is too far back. If the shell is positioned too far forward, it's going to hang up and not want to feed, and the carrier will just try and pick up the rear end of the shell, and it will cause a hilarious jam. So this piece is responsible for the fore-aft positioning of the shell. Of course, this can be printed. Ordinarily, it's made out of sheet steel. Fitting the sheet steel ones is quite a bit more tricky than the printed ones, right? Because the printed ones, you can just print it and then file on it. However, I did have to do just a little bit of filing on the receiver to get it to take the printed one, which isn't fantastic, but you can see that whoever had this gun before me had also sort of already went to work trying to make the gun work in a particular way, right? They'd ground out, and it seems to me they might have used like a little mini die grinder. So this receiver had already been attacked by someone, so I felt okay attacking a little bit further because I knew that I would be able to get it to work if I did that. And sure enough, the gun does now work quite well. Here is a close-up where you can just barely see. I'll see if I can touch it there with my pinky. That is that piece of nylon, that plate on the other side that we saw, and I can just barely wiggle it. It's very awkward to hold all this, but you can see me wiggle it there, right? So as the shell comes past, that piece gets pushed out of the way and it springs back into the way. And that's really all that it's doing is a wall that can be clicked in and out. But that's just about all there is to this gun's mechanism. I've seen a lot of people who have them struggle with understanding it, and we can take it apart further maybe in a future video that's specific to fixing feeding problems with this gun. But really all there is at this point is two little pins. Of course, you take this little torsion spring off, and then the bolt latch can come out of the gun by coming down and then up and out. The shell door lifts out by just being a bendy piece of metal, right? The shell door then comes out of the gun. You then have this pin, which really doesn't do a whole lot besides support the shell door and sort of make it so that the shell door has like a positive detent, right? It sort of clicks against that pin in order to like click into one position versus the other. Then this other spring is just responsible for holding a very funny looking torsion spring that just springs the carrier up. It also holds the carrier into the gun. Other than that, that's the mechanism, right? So everything that's left in this gun at this point is that torsion spring, the carrier itself, which is just pretty much a regular carrier, and then that plunger there at the front. If you've got one of these, I've seen a couple of these guns, in fact worked on a couple of these guns, where the plunger has been gummed up over time from use. Sometimes that plunger will need oiling and greasing. If you've got one that's seriously seized up, there's this pin, which is so it's a pin with its head pinned over, so it'll be difficult to get out. But once that's out, you can then remove the mag tube. Once the mag tube's removed, you can service this plunger guy there as you need to, right? If it's a little too gummed up to have to deal with. But otherwise, the only real thing to see here is this toggle, this wall as we've been calling it. It's a little tricky to get in and out of the gun, especially this nylon one here, but it has a little lip that sits into a tooth groove. You have to lift it up and then push it back. Once it's pushed back far enough, it will be able to pull off of this peg, like so. And then on some of them, you'll be able to get it out by pushing it through this side. Sometimes you'll have to snake them through on the inside of the gun by inverting them and then pushing them forward. And then you can sort of catch it through here. But of course, on mine, I opened that window up just slightly so I could get the nylon one in and out of the gun a little easier. But you can just sort of see, right? It's just got this knuckle. And the way that this works is as the shell is pushed past it, it bends out of the way, right? It bends, and then the shell can come past it, and then it springs back into place, and then it prevents the shells from coming backwards. Pretty much all it does. The steel ones are flimsy, get damaged easily. I've seen them cracked, bent out of shape, all sorts of horrible things that have happened to them. I have succeeded in making new steel ones. Maybe if like the 4 other people that have these guns are interested in making a new steel one or converting to a different shell length with a steel one, I can make a video about how I make those springs, but otherwise printing works pretty well. I printed it and then fit the part until it works correctly, but I'll just go ahead and throw this back into the gun there. And with that reinstalled, I mean, that's pretty much what there is to the 241. At this point, we'll sort of speed back through the reassembly because there aren't, I guess the only really tricky thing about the reassembly is that when it comes to reassembling the bolt, the first thing you have to do is the charging handle. But the reassembly order is important. We'll have to stick the charging handle in with the locking block all the way up, let the locking block come down. We then take this new, and of course this would be in the gun, right? So we'd reassemble the charging handle. Then we'd take this mechanism, depress the little flapper on the bottom of the gun, stick the charging rod mechanism in, make sure that it can get the locking shoulder to come up and down, which you'll have to be watching from the front of the gun. But once you've got this mechanism assembled like so, you can put the screw in it and then it will be reassembled within the gun. That's really the only thing to pay attention to on reassembly. Everything else reassembles just like it came apart. So we'll fast forward through that, do a quick couple of thoughts, and then go and shoot the thing. Alright, and there we have our 16 gauge 241 put back together. I guess a quick note for anybody who ends up having one of these things, if the wood panel's rattling, because on most guns I've seen the wood panels rattle, if that bothers you, you can just take a little bit, just like a small dab of RTV. I've used this specific RTV in the past. It will keep them from rattling so long as you don't remove them. After you've removed them, right, that RTV will generally stay stuck to the gun instead of the wood, and then you'll have to reapply it for each disassembly. So ordinarily I will do that after I've done a detailed cleaning on the things, just because the wood rattling is a little annoying, but it is just sort of the way the guns are, is that the wood panels give you a little bit of rattling. It doesn't quite show up whenever you shake the gun, because of course the sling swivels are going to be a little bit more loud anyway, but it is just maybe a little bit concerning because these wood panels are rather thin, and you'll see on a lot of guns they're fragile and can end up cracking. So having a gun with original panels, it's a little bit worrying, right, to have them rattle, but if you look at them, right, they're dovetailed into the receiver, and the way they're dovetailed, I think they'd have a hard time, popping out of there on their own. So that shouldn't have to be something that really gets worried about. But with the gun thrown back together, I think the only thing that I didn't note in complete detail for reassembly is that for installing the disassembly reassembly screw, the charging handle needs to be slightly retracted in order to bring the locking block down for that screw to be able to be inserted. So I struggled with that very quickly there on reassembly before noticing that. And then also on reassembly, you do need to remember to put the plug and then retainer into the stock before you put the end plate on, so that way the action spring has sufficient tension on it. But other than that, the gun does come apart and reassemble really easily. And ultimately, there's really only 4 screws involved in the disassembly. You've got 1 in the bolt, 1 to hold the stock onto the gun, and then 2 for the butt plate, but those only sort of count. And in this way, it is actually kind of cool because this gun isn't quite screwless in the way we've seen a couple of other designs be more or less screwless, or at least hand disassemblable, easier to disassemble than the Auto 5. And this sort of bridges that gap where it does still have screws, and they are screws that you end up having to have hollow ground screwdriver tips in order to get them out without damaging them. But it's a lot less reliance on that technology than you see on something like the Auto 5. Now, part of the way they get away from having to use so many screws is structural wood panels that hold pieces of the gun in and also retain pins. That's a little wonky. I can't say I'm a big fan of this particular solution. However, the wood panels do hold up okay, right? You're not really at risk of breaking them with them installed on the gun unless you're dropping the gun or beating it up. Really, it seems to me that the time that these panels get broken is on disassembly or reassembly of the gun. Specifically, reassembly, if you don't have the parts in the gun correctly and you just try and shove the wood panel on, they can very easily crack because they are so thin. But with a little bit of care and forethought, they do hold up pretty well. I think that's enough discussion of the way the thing comes apart and then goes back together, and then also how it works. Let's go and get some shooting with the thing to sort of show you the manual of arms and how it actually functions.
Well, we're outside with our 16 gauge CZ241. It's unbearably hot and humid today, but we're going to see if we can't make the best of it and have a little bit of fun here shooting some targets. As usual, our standard disclaimer, the targets are a little bit easy. We've changed up the angle of the targets just ever so slightly to maybe make it a little bit more interesting video to video. However, these are still pretty easy targets for me to shoot. The reason being, it's awfully difficult to see targets as they're in flight through a camera, so to try and prioritize you guys' viewing experience over me maybe having a little bit more interesting targets to shoot at, we're going to shoot targets that are pretty darn close. Jumping right into things, as we've already explained, loading the CZ241 is a little bit weird. You can't really just put shells into the bottom of the gun like you're used to because, as we can now demonstrate, if we take a shell and then put it into the primary position and then try and rack the bolt, sometimes it will feed it, but usually it will hang up kind of hilariously and require finagling, and now we're going to have a great big jam to clear. This is what usually happens whenever you do that. Now, the proper way to load it involves putting one round directly into the chamber first, and then putting rounds into the bottom of the gun. Of course, it's got one round in the chamber plus 2 rounds below for total capacity. Whenever you're putting a round in below, it will click once as you push it forward, but that's not fully inserted. It will click a second time as it gets past that finger, and that's how you know that that shell is seated. We will then put a second shell onto this little clip retainer there on the trigger guard, and at this point, the gun is loaded to its 3-shot capacity. And at this point, we are ready to fire. The thing does shoot pretty darn smooth. Of course, it is just a 16 gauge, but it's a fairly light 16 gauge. I would say overall the recoil feel is pretty darn smooth. Compared to a 16 gauge Auto 5, maybe not quite as smooth, but it's really not that bad. After expending those 3 rounds, of course, reloading is the same process. 1 round into the chamber, and 2 rounds underneath. Of course, top-off reloading can be accomplished if you just shoot 1 round. We can demonstrate that here. If we just put 2 rounds back into the gun, and now we'll demonstrate what a top-off load is like with this thing. We'll just shoot 1 round, then flip the gun over and reload it. Then reloading is this awkward process of sliding the trapdoor forward, putting 1 round in, closing it, and now we'll try 2 rounds and then reload those. Interesting little feeding hang up there. And reloading 2 rounds is just like follows. Put 1 round in, it'll click once, make it click twice, and now it's fully inserted. Then we will take our next shell, put it in, and the gun is ready once more. Let's just go ahead and shoot these 3 rounds, but we'll shoot with the gun from the hip whenever the bird is pulled, just to sort of simulate what snap shooting is like with the thing. The gun is light enough and points well enough. I don't think we'll have too much trouble with this, but just for fun. Interesting, that bird threw a little lower, but that was entirely my fault. I think I may have shot under it. There we go. And there we go. So that's about what it's like. And that's really all that there is to the CZ241. I think we can do a little bit of slow-mo footage just because that's always fun, but otherwise there's not a lot of tips or tricks to the thing. Its loading mechanism is a little bit confusing and it does take practice to get used to, and all things considered, it's not the most reliable gun. So far today it's ran pretty well. I think we just had that one jam where I sort of had to assist the bolt in going forwards, but sometimes these guns will just decide that they don't want to work very well. I've noticed that them being spotlessly clean does tend to make them run more reliably, but feeding issues are just sort of there. It's a present thing on these guns, and I don't know that there's necessarily a way to fix it. It just comes down to how sort of wonky the feed geometry and feed mechanism is. Because, of course, as we can demonstrate here, I guess we can get loaded up for our slow-mo now, but just to be able to show you guys, if we go ahead and load the gun up, 1 shell, and it goes forward against its spring, and it's held in there tight. But the second round that goes in there has enough room in there to rattle. And I think that rattle zone is a little bit of what contributes to the gun having sometimes a little bit of feeding inconsistency. Is the actual location of that second round can be various places, and that little pawl on the bottom of the bolt that's trying to pick it up and move it forwards may not necessarily pick it up at the same place and at the same angle every time. But with that discussion aside, let's go ahead and see if we can't hit a couple of these targets in slow motion.
Well, we're back inside with our CZ241. We'll just do a couple of closing thoughts and then send you guys on your way. The CZ241 is not a shotgun for the light of heart. And what I mean by that is, a lot of the times that you'll find them for sale, they'll either be missing parts or in need of work. Even once you have one that's in working condition, it really only wants to work with shells that you can't actually buy these days. Converting it to work with modern shells for 16 gauge guns isn't impossible, but it does involve knowing what you're doing and a little bit of gunsmithing. Converting 12 gauge guns is really a question of converting them to 2.5 inch, and then you're still in a situation where ammo is pretty darn expensive. And between shooting 16 gauge in general and shooting 2.5 inch 12 gauge, you're looking at a gun that's pretty expensive just to be able to shoot. And then what you're getting for that added expense is, I guess, a gun that points pretty well. They balance okay, but that's pretty much the end of the desirable things about them. Even once converted, they're a little temperamental about feeding and cycling. Loading them is a slow, arduous process that has to be done correctly, or else you can get the gun into a situation where it's like a 30-second to 1 minute unjamming process where you're sticking fingers into places where fingers can get smashed, and generally just an unpleasant experience. Your chances of finding spare parts for these guns really comes down to buying an extra gun that you can take parts from, or again, being fairly involved in gunsmithing and making new parts for the thing. And ultimately you have a gun that, all else being equal, probably isn't as good as just a super lightweight Auto 5. Really doesn't have anything that it offers that a super lightweight Auto 5 doesn't offer better. Maybe this balance is just a touch nicer, but in consideration of all other factors, that's really water under the bridge. A super lightweight Auto 5 is a substantially better gun than these. And whenever you get down to it, they're both about equally rare here in the States. So while I can certainly understand what the Czechs were trying to do with this, right? They're trying to think outside the box and really min-max what a shotgun might need to do, because certainly loading this thing is maybe a little bit faster than a side-by-side or an over-under, so it having 3 rounds on deck and then being able to be reloaded about as fast, I can understand what they were trying to do here. And I can understand that why during Nazi occupation the Nazis were interested in seeing development of the shotgun continue. Certainly the thing showed enough promise to be worth further development, but by the time the war ends and then the gun actually sees mass production, I don't think they quite worked out enough of the wrinkles in the gun. Maybe if the gun had stuck around for longer and the Soviets hadn't ended production, we would have seen different latches for the gun so that it could be capable of running more modern shells as more modern shells became more standard. But as things stand, these guns are temperamental, pretty much impossible to replace parts on. Despite what CZ's marketing at the time about the guns says, they do break parts, right? You will find guns out there with broken charging handles or broken firing pins. I've seen guns with cracked trigger guards, right? Really, there's a whole glut of things on these guns that can break. And then when you find them used, right? I've seen separated ribs on 12 gauge guns, stocks cracked in hideous fashion, forends cracked. You can run into all sorts of problems with these guns. And combating those is going to be quite a gunsmithing task. And your reward at the other end for that is a gun that's pretty much worse in every way than an Auto 5 that just has wood panels on the side that look kind of cool. And that's really what drew me to the CZ241. I like them. I would like to get a 20 gauge to sort of round out my collection of them. But by no means is this better than an Auto 5. I know a lot of the guns we've looked at that came after the Auto 5 at least have something better to offer. Maybe this one has like less screws in its disassembly. If we're really to try and find a very motivated reason to say that this is better, I guess it's got less screws in its disassembly. But otherwise, there's not a lot going on here that's particularly novel or unique. Of course, as we discussed earlier, right, it does have that weird intersection with an Italian prototype with its feeding mechanism that later shows up in the double auto. This was influential at least in that regard, but you don't see a whole lot of other shotguns follow in its footsteps. With the very limited exception of maybe a one-of-one prototype that was made in Soviet Russia where they had a CZ241. I'm not entirely sure what's up with that. One day I would like to maybe explore a little better the history of the Soviet sporting shotguns. In a future video we'll be able to feature the Soviet long recoil shotgun as a part of the NATO 5 series, but there's a lot of very small production number prototypes, like the Soviets made a gas-operated Cosmi-style shotgun, mag in the buttstock but gas-operated out front. It seemed like they were doing a lot of experimentation with was out there in the sporting shotgun world before ultimately settling on a pretty conventional long recoil design that we'll be able to look at in the future. But back to the CZ241, just to sort of wrap up my thoughts on this gun, they are very cool. The way they work is certainly unique, but nothing about it is good unique. It's generally tipping in the direction of this probably wasn't the best way to do this for any sort of reasons or any consideration. The Auto 5 is, I think, less mechanically complex. Whenever you consider the total mechanical complexity going on here, I don't think you're really saving much compared to the Auto 5. Maybe the receiver's a little simplified in terms of cuts needing to be made on the inside of it, not just on the rails, but the fact that the pockets for the feeding mechanism are on the outside of this receiver as opposed to the inside on an Auto 5. I think you're maybe gaining some slight advantage in manufacturability there. but that's pretty close to it. And I don't think those changes really translate into the things that I'd say are good about this shotgun, because certainly the way the receiver's set up isn't a good thing about the shotgun, it's really just a simplification or a cost savings thing. The good things about this shotgun, sort of the shape of the stock and the way it points and handles and swings and balances, all of that can be accomplished pretty much without having to use this sort of a setup or this sort of a receiver, and I think the double auto is probably the best proof of that. You can just have this action, but shorter, and pretty much the same feed mechanism, only have it be easy to reload, and it goes much further as capturing the potential benefits of that limited capacity automatic shotgun that the CZ241 really leaves on the table. But with that all said, I hope you guys have enjoyed this interesting chapter in the Not 05 series. It might not be the most effective and was one of the most short-lived, but it is still a very, very interesting gun. If you guys have liked this video, or like videos like this, or videos that aren't like this, because we do a lot of that too, you can find a link to my Patreon in the description. You can support me there. More support means more videos quicker. Sort of just the way that math works out, but even just liking or subscribing or leaving a comment helps me as well. I hope you guys had a good time. I hope you enjoyed looking at these particularly weird shotguns, and I hope you will stay tuned for whatever we have next.